The following is Melanie's Fall 2011 Math 227 Test 3, number 9. A cereal company claims that the mean weight of the cereal in its package is 14 ounces. That's the mean weight. Okay. The weights in ounces of the cereal in a random sample of 8 of its cereal packages are listed below. Test the claim at 5% significance level. Assume that the sample has been randomly selected from a population with a normal distribution. So let's see. We have that data there. We know that we are told that the number of data is 8, and then x bar will be, if I compute the x bar, I will add all the x's divided by n, right? The sum of all the x's, if I add them, is 14.6 plus 13.5 plus 14.4 plus 13.7 plus 13.8 plus 13.7 plus 14.1 plus 14.4. 1, 2, 3, 4, 5, 6, 7, 8. The sum is 112.2 over 8 equals to 14.025. Now, the sample's variance, on the other hand, equals to n times sigma x squared minus the square of the sigma x over n times n minus 1, which is 8 times sigma x squared will be the sum of the squares there, 14.6 squared plus 13.5 squared plus 14.4 squared plus 13.7 squared plus 13.8 squared plus 13.7 squared plus 14.1 squared plus 14.4 squared. That will be 8 times 1574.76 minus 112.2 squared big over 8 times 7. That is equals to 8 times that answer, minus 112.2 squared. Divide that by 56. I get 0.165. Oh, that's a small one. So the sample standard deviation will be the square root of that, which is 0.40620. Okay, now that's the information we have. Now then, let's start with the hypothesis testing. Step 1, the claim that the mean weights of the cereal is 14 ounces. Okay, the second, the hypothesis the null hypothesis is the one with equal sign. The mean weight is 14, means the alternate hypothesis is the mean weight is not 14. You will see later on, this is a two-tailed test. Okay, step 3, the test statistic. We don't have the population standard deviation, so we will use a t distribution later on. Okay, the t star equals to the sample mean 14.025 minus the claim mean big over the standard deviation is 0.40620 over square root of 8. If I compute that, that is that will be 0.025 divided by the standard deviation multiplied by square root of 8. That will give me the t is 0.17408. Step 4. Step 4, the critical value. You see, we will use t distribution, right? And then the significance level is 5%. So this is 2.5% here. This is 2.5%. Now when I take a look on the t distribution table, the area in totals is 5%. The degree of freedom is 7. It's 2.365. 2.365. So this is 2.365, and this one is negative 2.365. Right? That's the critical value. That's plus minus 2.365. Okay. Now then we can see from the situation here, the test statistic is well inside the acceptance region. So step 5, the informal conclusion. We say we accept null hypothesis. Okay. So step 6, the conclusion. We say that at 5% significant level, the data supports the claim. The claim that the mean weight of the cereal is 14 ounces. Okay. Now if we want to follow our textbook, then our textbook will say at 5% significance level, the data is sufficient to support the claim, or maybe they say fail to reject the claim that the mean weight of cereal is 14 ounces. Okay, they use the phrase fail to reject maybe. Okay, but we don't really need to follow that claim from the book, that the conclusion has to be said that way. Okay, it is actually a quite acceptable practice right now to say this way. Okay, the data supports the claim, you know. Okay, or maybe some people try to be a bit careful. They say the sample data appears to support the claim that the mean weight of the cereal is 14 ounces. Okay, this is from Melanie's fall 2011 Math 227 test 3 number 9.